Wow, that's really loud. Everyone hear me? Awesome. This is Elasticsearch with Kafka, keeping multiple data centers in sync. If I can start this presentation. About me. I'm a computer science grad from University of Western Ontario. I worked at BlackBerry before I came here for about 11 years, BBM and configuration management. Really, that means chef. Built BlackBerry chef infrastructure. I've been at Shopify for about a year now, and I support Kafka, Elasticsearch, and Zookeeper. Oh, and I bike a lot. I actually cycled here tonight. And I really, really hope that it's not going to rain on the way home, because then I'm going to get wet. In terms of what I'm going to talk about, some motivation for running multiple Elasticsearch clusters, why we do that here at Shopify, go through what we came up with as a solution, and go through some of the implementation details and some of the problems we faced, and a couple points on future work, and then I'll take some questions. So, motivation. This is what we were running about a year ago. This is a really simplified diagram. Our real implementation is a lot more complicated than this. It has a lot more boxes, but unfortunately I only have limited slide space. The crux of it is that we have a massive Rails application that talks to MySQL for all of its data. MySQL gets replicated between data center A and data center B. And we have two Elasticsearch clusters in each of those data centers, one that's active and one that's standby. So it isn't queried at all. It isn't written to at all. We use S3 for backups, and every so often we will restore a backup to that red cluster on the right. If a data center goes away, like a bomb hits it or something, we're in a lot of trouble because we need to do a snapshot restore pretty darn quickly. And it takes a while. I've done this before, and it took about 6 hours, so 6 hours downtime is a lot for us. In terms of sizing for a cluster, we each of those is 22 nodes, about 100 terabytes of storage, and 5 terabytes of memory. So, a couple of ideas. How do we fix this problem of having active standby and have active? First idea, well, why don't we just run Elasticsearch across the way? Have 50% of the cluster on one side, 50% on the other one. As the guys from Elastic who are here will tell you, don't do this. This is a really, really bad idea. Not only does the complexity increase as the number of data centers grows, there's high latency, it's unreliable connectivity. If your data center goes away, your data goes away. However, if you're running in Amazon, cross-AZ is okay, and it's okay to do that. Just don't do cross-region because it has the same problems as that. So don't do this. And this isn't what we do, for what it's worth. So, next option. Let's shard our data. Let's put kind of 50% in data center A, 50% in data center B. So each data center kind of owns part of the data. In fact, Shopify actually does this already. All of our MySQL instances are sharded. So we run kind of 50% of our databases in data center A and 50% in data center B, with standby databases in the opposite data center. We also can't do this, because if there's a data center outage, 50% of our customer data will be gone or unavailable. What we actually want is true active, so that if we lose a data center, all of our customer data is there and can be queried, and everything works flawlessly. Which is why we built this. So if you'll notice, there's a message queue in the middle there that's basically shared between our data centers. Again, our Rails application queries Elasticsearch. but that's only queries. Writes go through the message queue. And you'll also notice that Rails queries its local Elasticsearch that those queries don't go over the WAN anymore. So we had to teach Rails to write to a replicated message queue. We had to teach some consumer on the other side to read from that message queue. As well, we still do Elasticsearch snapshots. We do those regularly. So in terms of implementation details, this previous diagram, that message queue is actually Kafka. And so we decided to use it. So what's Kafka? It's this really fast distributed streaming platform. It's really scalable, distributed, replicated logs, super fast publish, subscribe system. Supports one producer and multiple consumers, so multiple people can consume the same data. It's not like a message queue in the general sense. Supports consumer failover. It's used here for our logging pipeline, our analytics, our data warehouse, a whole bunch of internal apps, and of course, Elasticsearch replication. So this is what it actually looks like. Our Rails application, oh, by the way, I've removed MySQL just because there was too many boxes here. Our Rails application produces Elasticsearch documents to a local Kafka instance in its local data center. We call those the regional Kafka clusters. Elasticsearch documents are consistently hashed to a single partition or a single server there. That makes sure that we preserve ordering on Kafka. Otherwise, it would go to a random server, things would get out of order. That's bad, don't do that. We also use a Kafka technology called Mirror Maker to mirror to the middle Kafka cluster there. We call that our aggregate. Both of our Kafka consumers consume from that. We call our Kafka consumer Elastic Bridge. So we've got 64 of those running in each of our data centers, consumer from Kafka, and writing documents directly to Elasticsearch. And again, each Rails cluster queries its local server. So literally the time to fail over Elasticsearch is reduced to the time it takes to fail over Rails and MySQL, which is, I don't know, a couple minutes, which is pretty darn good, going from 6 hours to a few minutes. In terms of how much throughput we get, we've seen 1 million documents a minute through this pipeline, which I don't know if any of you guys have clusters similar size, but it can certainly handle the amount of throughput you can throw at it. Actually, in this, Rails doesn't fall down, Kafka doesn't fall down, our producer doesn't fall down, Elastic Bridge doesn't fall down, Elasticsearch itself, we saturate this guy up. So, a couple challenges. In terms of high-level steps, when we do re-indexing, when we need to grab all the stuff from MySQL again and stuff it back into Elasticsearch because we've changed the schema or something, we need to ensure that the new index gets created before we start re-indexing those documents. Otherwise, the documents go to the old index, they're lost when we switch, that's bad. So we introduced this concept of metadata so that it's not actually an Elasticsearch document, it's more an action to do something like create new index or switch to a new index, delete documents. In order to preserve ordering, we need to ensure that all the new documents go to that new index, so we send this create new index metadata event to all Kafka partitions to ensure that it gets consumed first. And then we wait until at least one creates the index. And however, we don't do the same thing for switching to a new index. It doesn't really matter if we don't capture 100% of the documents right away, because we know it will catch up within a few seconds. Re-indexing delays. So we actually have this problem right now. We're trying to solve that. As I said, when we do occasionally overload our Elasticsearch clusters in terms of disk I/O, even though we use really fast SSDs. We've seen delays up to a couple of hours, unfortunately. So a couple of ideas. We can add more Elasticsearch capacity, which we've done before. We've done already, but that gets really expensive really fast. We could do a separate Kafka topic, which we've taken a look at, but we thought that wasn't actually viable because we need to preserve ordering, and having two topics doesn't preserve ordering. What we're actually going to implement is a throttle between the consumer and the reindexer. So the Elastic Bridge will write some metadata into a central store, and then have the Rails producer look at that, and if it's going too fast, it's just going to sleep until the light goes down. So, future work, implement that reindex throttle that I just talked about, and extract all of that Elasticsearch code into reusable gem, which we've done already, and I'm really hoping to open source soon, so that all you guys can take a look at it. So, in summary, running one Elasticsearch cluster for a highly available product is a pain in the neck. We use Kafka to provide a log of Elasticsearch documents. Consume those in each of the data center, so all of our Elasticsearch clusters are in sync within a couple of seconds of one another. Reindexing is a big challenge, and it continues to be so for us. And we're going to reuse this for a bunch of other internal products. We use Elasticsearch all over the place, but only our core app actually uses this today. So we want to extend this to all of our other apps, which is really neat. So, again, this is me. Thanks very much, and I'll take questions.
Do you use containers in all this deployment?
Do we use containers in this deployment? Kind of. So we've got a few deployments in our data centers. Elasticsearch is run in bare metal, as is our Rails application runs in containers. Kafka runs on bare metal, and Elastic Bridge does also run in containers. We're also experimenting with GCP, where basically 100% of it is in a container.
What is GCP?
Google Cloud.
Okay.
So what mechanism are you looking for the Kafka throttling? Are you thinking something on the Kafka side, or something on the Elastic side, or something in between?
Ooh. The question is about throttling.
Yeah, your throttling mechanism, because it definitely would be interesting to a lot of people. Is it something that you plan on running in between Elastic and Kafka, or is it something you want to add to one of the two products?
Currently, the idea is to put the lag into something like Zookeeper, and have the producers watch that lag, and depending on some sort of thresholds, sleep for a period of time. That certainly isn't set in stone, and if anyone here has any super smart ideas, I'm all ears, because it's a problem that we need to solve.
Are you using Logstash or Beats to get your data from from Kafka into Elasticsearch?
No, we wrote our own consumer that we call Elastic Bridge. So our gem is Elasticsearch Shopify. We actually started writing our Elasticsearch stuff before you guys had a gem. So unfortunately, we're duplicating work. At some point, we'll think about merging that stuff. But yeah, go ahead.
Elasticsearch cluster by itself doesn't support replication between replicas.
Elasticsearch does not support replication today. These fine folks at the back may tell you that it's coming in 6.0 or 7.0 or...
Not in 6.0, but I'm hoping we see some early betas in the 6x line. We've done a lot of the foundation work that needs to be done to do multi-data center replication. The have to rely on an external component to be able to do it. And Kafka is a good example. Kafka is awesome. I have no problems with it whatsoever, but we would, just like the Zookeeper issue, we re-implemented what Zookeeper does internally in Elastic with this component called Zen. Zen is the coordinator that basically keeps the consistency model correct. So we did that in-house, even though a lot of people told us that's a dumb idea. You might as well just do what Zookeeper already does. And we're probably going to end it, but we did it because you can go from a single node cluster to a multi-node cluster with one configuration. And we want multi-data center replication to be exactly the same thing. We want it to be like a one config line type of option to make it happen. So the solution will come a little slower, but we're hoping it's going to be super easy for the user. You'll find out more. Like, we're going to talk about it in blog posts and things like that as it comes out. But the piece that we finished is that we didn't have the type of write-ahead log that would be necessary for doing multi-data center setup. It was really designed for like a single data center setup. If the transaction IDs numbering that is really critical for that, that actually got added to the most recent version. That got added in the 5X series, and it got expanded on in the 6X series. So we've got all the scaffolding in place to do it. We'll just have to see how it shakes out.
The presentation makes it seem really simple. What we did, it was pretty darn hard and pretty darn hard to get right. It required a ton of testing and a ton of work by a whole bunch of people.
We have a bunch of customers who are using pretty much the same technique that you're using. Sometimes with Mirror Maker, sometimes without Mirror Maker. It depends on when they started with Kafka, because Mirror Maker is relatively recent. So it's still the right way to solve the problem for today.
Anyway, I'm certainly looking forward to the native replication.
No.
That'd be really cool.
I'll take the
Yeah, go
problem.
In order to get the throughput you want in Kafka, how big of a cluster do you have to run? Like, you said you're doing millions of
So the Elasticsearch part of our Kafka cluster is tiny. Literally, I don't notice that the documents are going through. Each of our Kafka clusters is 12 nodes, 256 gig boxes, 30 terabytes of high-speed storage. Small.
So you guys are using that for enterprise message bus as well, and loading a bunch of event-based data that's on there for other applications?
Oh yeah, we use it for all of our analytics. We use it for all of our logging. Every one of our requests goes through there.
Just curious about your delivery semantics on the Kafka too. What exactly are you using? There's two different types of possibilities you can have. That's exactly one, right? Most ones are.
Well, we certainly don't have exactly ones because that's only available in the latest Kafka, and it's only for streams.
Was there challenges there, like based on what the delivery semantics you use?
Yeah, so our documents are idempotent. So if we process them multiple times, that's fine, which is what we do, right? If a consumer crashes, it doesn't checkpoint. I think we checkpoint in like batches of 1,000 documents or something. We tried checkpointing faster than that, and we don't get the throughput if we don't batch.
Have you tried, or have you had yet to add a new data center to this cluster? And if so, have you run into any challenges with that?
Yeah, actually, we've started moving to Google Cloud since this was implemented, and literally we restored a snapshot that was 4 hours old and replayed all the Kafka data for the last 7 days, and it was in sync, and it took, 4 hours. Yeah.
What's the motivation to move to Google Cloud?
Sorry, what's the question?
What was the motivation to move to Google Cloud?
It's cooler.
Yeah, it's cooler.
You've got access to PubSub in Google Cloud. You've got their TensorFlow stuff. They've got a whole bunch of like machine learning APIs if you're interested in things like that. Like I have a demo where I take advantage of the Vision API that they provide for identifying images and extracting text out of like an actual image. A lot. I guess Amazon has some of that stuff. But I don't think Amazon has Vision API.
So we run all of our core applications in containers. Our container management isn't great. We started down some roads looking at Kubernetes ourselves, and we figured we may as well just pay Google to do it and click buttons in the UI and focus on writing our core application rather than running Kubernetes.
Did you consider Azure too?
But we did not consider Azure.
Because it has machine learning.
It's fine.
I don't think there's any Microsoft people here tonight.
No, we all use Macs. And all of our servers are Linux. So I actually don't think we have any Microsoft products.
Tableau.
We have Tableau. Thanks, Angie.
Azure actually does have an Elasticsearch. They have a search product that you can use that's actually elastic under the covers. We also provide templates in. So we have a deal going with Google right now where we're going to be setting up Elastic Cloud, which is our own hosted service in GCP as well, which is also on Amazon at the moment. We don't have it with Azure, but we've got templates there. Templates are kind of cool. Like if you have to roll out a system of, you want X number of servers, you just type in some numbers and it'll go. It's not as easy as the cloud product, but it's not hard to use. It comes down to how hard you are on your Azure websites. You get a lot of free credits in your hardware. I didn't say that. It's awful.
The reason why I'm asking because Microsoft is moving right now to the open source world, yeah. So they say price-wise they are competitive with Amazon and Google. So there are different school of thoughts which provider you know. It looks like Amazon has all this market for accessing the service and trading or something that other platforms, I don't know, they are working on it or something, but they are like neck and neck having features and stuff.
We're trying to keep our platform cloud agnostic. So again, if Azure turns out to be cheaper, we can move there tomorrow. Right now, Google seems to be giving us the best deal, so we're with it.
Test your performance. If you're switching from Amazon to Google Cloud to Azure, test your performance on your actual workloads. There's reports of certain cloud vendors being a little bit slower, actually being a lot slower than what you're doing. Google's got really good CPUs. They kind of market themselves as a premium cloud service. Their IO is pretty decent as well. I mean, you guys have probably done the testing. What do you been
Their
seeing?
IO is actually better than we want.
IO is, yeah. It's better than us.
Any other questions? Yeah.
How do you resolve conflicts? So if there is at the same time from one data center a document is updated and from another deleted, so how would you resolve this conflict in your application production? Or do you have it?
So because we're sharded, essentially each Rails instance in a local data center owns a document ID. So it will only ever come from that data center unless we fail over. And a failover is slow enough that in practice that problem doesn't happen. Right? So our data centers are active, but if you look at our application, it's actually active standby. We just have multiple active containers in both data centers.
Kafka gives you sequencing, so you can potentially use that sequencing to solve the problem.
Yeah.
Ahmed, you're up.
Thank you.
Thank you, everyone.